Hello and welcome to today's little tutorial video. In today's video we are going to be practicing some wave speed problems. So in these problems we will be calculating the velocity of a wave, the frequency of a wave, or the wavelength of the wave. And real quickly before we get started, there are a few symbols and terms that we need to go over. So first of all, you can see this symbol V. The term that goes with that is wave speed. We measure the wave speed in meters per second, and our symbol is m/s. This little lambda symbol stands for wavelength, and the wavelengths that we will be using for these problems are meters, and our unit symbol will be the m. And the F stands for frequency. The unit of frequency is hertz or per second, and the unit symbol that we use is Hz, the abbreviation for hertz. So let's go ahead and get started now. Our first problem says, a wave with a frequency of 14 hertz has a wavelength of 3 meters. At what speed will this wave travel? So the first thing we're going to do is write down our knowns and unknowns. My pen is having a little glitchy moment, so we will go ahead and do that. Our first known is frequency, so I'm going to write F equals 14 hertz. Wavelength is 3 meters, so we're going to write wavelength 3m. And our unknown is speed, or v, so we're going to go ahead and write that. The next thing that we write is our original equation. So for this one, we're going to be calculating speed, so v equals f times lambda. Next, we go ahead and plug in our knowns and unknowns. We show our work. So V equals frequency 14 hertz times wavelength 3 meters. Please make sure that you show your units so it helps us understand the math and what units we should get out at the end. And in a calculator, we're going to say 14 times 3 equals V equals 42 meters per second. All right, so that is question number 1. Question number 2 says the speed of the wave is 65 meters per second. So V equals 65 meters per second. If the wavelength of the wave is 0.8 meters, so wavelength equals 0.8 meters. What is the frequency of the wave? So frequency is our unknown. The equation that we need to use for this, if you take your original equation and divide both sides by lambda to get frequency by itself, we get F equals V over lambda. And now we can start plugging in and showing our work. So frequency equals 65 meters per second divided by 0.8 meters. You can see here our meters are going to cancel out. And so when I plug that in to an equation, I get frequency equals 81.25 hertz. We won't be worrying about significant figures today. Question number 3 says a wave has a frequency of 46 hertz and a wavelength of 1.7 meters. What is the speed of this wave? So there again, I've got my knowns and my unknowns. I start off with my equation v equals frequency times lambda, and velocity is what I'm looking for, so I can just leave it just like that. Showing my work, speed equals 46 hertz times 1.7 meters. When I plug that into a calculator, my velocity comes out to be 78.2 meters per second. Question number 4 says, a wave traveling at 230 meters per second, so speed is 230 meters per second, has a wavelength of 2.1 meters. Wavelength equals 2.1 meters. What is the frequency? Frequency is what we're looking for. Next, my equation, v equals frequency times wavelength. I need to get frequency by itself, so I'll divide both sides by lambda. And I see frequency equals v over lambda. I'm going to go ahead and plug in my knowns. F equals 230 meters per second divided by 2.1 meters. Again, you can see my meters are going to cancel out. And I will get frequency equals 109.5 hertz. So you can see these problems are all pretty much the same. They're not too difficult. Starting with number 5, a wave with a frequency of 500 hertz. So frequency equals 500 hertz. Is traveling at a speed of 200 meters per second, so v equals 200 meters per second. What is the wavelength? Oh, whoops, I appeared to have switched colors. So lambda is, let's see, my unknown. There we go. So let's go ahead and write in our equation, v equals frequency times lambda. And lambda, or wavelength, is what I want to get by itself, so I need to divide by f. And I get lambda equals v over f. So now I can plug in my numbers. Lambda equals 200 meters per second divided by 500 hertz. And I get wavelength is 0.4 meters. Let's go ahead and look at number 6. A wave has a frequency of 540 hertz and is traveling at 340 meters per second. What is its wavelength? Okay, then I will go ahead, velocity equals frequency times wavelength. I'm looking for wavelength, so divide both sides by frequency, and lambda equals v over f. I can plug this in. Lambda equals 340 meters per second divided by 540 hertz. 340 divided by 540 gives us a wavelength of 0.63 meters. Remember, if you don't show your work, it makes it really hard to evaluate what do you understand and what are you unsure about. So showing your work really helps teachers and graders to help you clarify where you might be confused. So always, always, always show your work, show your knowns and unknowns. It's really important. Question number 7 says a wave with a wavelength of 125 meters, so wavelength equals 125 meters, is moving at a speed of 20 meters per second. What is its frequency? So we are looking for frequency here. Velocity equals frequency times wavelength. Divide both sides by wavelength. Gives me F equals V over lambda. Showing my work now. F equals 20 meters per second divided by 125 meters. And I get out a frequency of 0.16 hertz. Number 8 says a wave has a frequency of 900 hertz and a wavelength of 200 meters. What is the speed of this wave? So V equals F times lambda. That we are looking for V, so now I can plug in my work. V equals 900 hertz times 200 meters. And that gives me, change my color, a speed of 180,000 meters per second. Number 9 says a wave has a wavelength of 0.5 meters and a frequency of 120 hertz. What is the wave speed? So again, I'm not going to need to rearrange this equation because I'm looking for wave speed. Wave speed equals 120 hertz times 0.5 meters, and that gives me a wave speed of 60 meters per second. All right, on to our last page. Radio waves travel at a speed of, I need more room for this, 300 million meters per second. WFNX broadcasts radio waves at a frequency of 101,700,000 hertz. What is the wavelength? I know this one seems harder because there are really big numbers, but it's just the same steps that we've been doing. V equals F times lambda. I want lambda by itself, so divide both sides by F. Lambda equals V over F. Show my work. Lambda equals 300 million meters per second divided by a frequency of 101,700,000 hertz. Definitely going to use my calculator for this one. And I get out a wavelength of 2.95 meters per second.